Welcome to this video on the topic of matrices. In this video, we'll be having a look at how we can apply scalar multiplication to matrices. Now, scalar multiplication is simply a way in which we can scale or dilate every single member within a matrix by a set factor. Now, if we turn our attention to matrix A over here, we've got a generic matrix with no real information or dimensions set inside it. What we're going to do is we're going to multiply the left-hand side of the matrix by a scalar value of k. K being something like the value of 1, -3, x, or x plus 2. So basically we're looking at just some generic values that we would have seen in our algebra up until year 11. Now the consequence of multiplying the left-hand side by k here, what this is going to do is every single element or member, depending on what you want to call them, inside the matrix is also going to get multiplied by the value of k. Now this phenomenon we see here, we call this scalar multiplication, as in every single member is scaled by the value of k. Now applying this principle to some examples below. In example 1, we have a scaling factor of 3. And we have a matrix A defined as 4, 1, 3, 2. What we're going to do is we're going to compute the scalar multiplication of k and A. Now writing this out, we're going to get the value of k is equal to 3 in this instance. So we're going to go 3 times. Now as mentioned, the value of k, so 3, is going to propagate through all of this matrix here. So the result of this particular multiplication that we see here is going to be 3 times 4. Then we're going to go 3 times 1, followed by 3 times 3 and 3 times 2. Notice how I'm setting my matrix out once again, making it nice and neat so the calculations are easy to follow through. Finishing this off, 3 4s are 12, 3, 9 and 6. So we've been able to scale our matrix A by a factor of k, or scale our matrix A by a factor of 3. So everything inside has been scaled up or multiplied by the value of 3. Now, doing this in example 2, we have a scaling factor of 1/2 and B. Setting myself up for success, KB. And the scaling factor is 1/2, like so. B is still 12, 8, 6, 4, 3, and 16. Performing the multiplication, I'm going to go 1/2 multiplied by 12, 1/2 multiplied by 8, and so on. Finishing this off, 1/2 times 12, or 12 divided by 2, is simply 6. 1/2 of 8 is 4. 1/2 of 6 is 3. 1/2 of 4 is 2. 1/2 of 3, well, it's going to be a decimal, so I'll just leave it as 3 divided by 2. It's nice and simple. And 1/2 of 16 is 8. So KB in our case turns to 6, 4, 3, 2, 3 over 2, and 8. So 2 examples demonstrating how we can apply scalar multiplication. Now, verifying these results using our technology, I'm going to bring up the calculator and I'm going to import matrix A and matrix B into my calculator here. So going into exit a few times to go to the top menu and pressing F3, I'm going to import matrix A and import matrix B. Alright, going for the matrix arithmetic, I have to click on Option, F2 for Mat. Then I'm going to go, my k is a value of 3, so I'll put in 3, then in brackets, I'll go mat alpha A, close it off, execute. And what we come up with is a result of 12, 3, 9, and 6, which is in agreement with what we get over here. Now applying this for matrix B, we have a k value of 1/2, so we'll go 1 over 2, multiplied by F1 for mat alpha B, execute, we get 6, 4, 3, 2, 3 over 2, and 8. Or if I press the SD button over here, it gives me it in a decimal form. So 3/2, same as 1/4 or 1.5. So in conclusion, what we set out to do in this particular video was we wanted to have a look at how we can apply a scalar multiplication to matrices. And then we had a go at doing 2 examples, finally checking our solutions using our technology as seen here.